Hello everyone, welcome to the Litmus video tutorial. This is Karthik, maintainer of the Litmus project. In the previous episodes, we discussed cloud native chaos engineering. We introduced ourselves to Litmus project. We discussed the LitmusChaos architecture. We saw the different components of the Litmus framework, how they behave and contribute to the overall execution of a chaos experiment. We even got started by running a pod delete chaos experiment. We pulled the experiment CR from the hub, we created the chaos engine CR, and we visualized the result using the chaos result. In today's episode, we will discuss another abstraction or another way of running Litmus chaos experiments called as chaos workflows. Now, chaos workflows was a result of certain real-world requirements in the chaos engineering space as identified by the community, notably by the folks from Intuit. So we're using a popular cloud native workflow management software or engine called as Argo. This is also listed on the cloud native landscape and is an incubating project in CNCF. Litmus is making use of the Argo workflows in order to construct complex chaos scenarios. In today's episode, we will discuss what is the need for chaos workflows, how a chaos workflow can be constructed, how it can be executed, and how we can visualize the results of the experiment and they have been run using the chaos workflow. So let's get started then. Let's take a look at the agenda we have today. We'll try to understand chaos workflows, and we'll also look at why they are needed and where they're used, the use cases associated with chaos workflows. We'll run a sample workflow during this session, and as part of that, make use of the same pod delete chaos experiment, which we've already used in a previous episode. And we'll also look at the Litmus portal. We'll talk about it very briefly. So Litmus portal is a sub-project within Litmus. It is under development right now. There is a tech preview that is available on the LitmusChaos/Litmus repo that you can use. An alpha version of the same should be available by the subsequent release of 1.8. The portal is something that's going to help you orchestrate your workflows in a simple way by providing you with a user interface and also tell you how your workflow runs have been over a period of time. I'm going to use the Litmus documentation in today's session. We'll use the docs to go through what chaos workflows are and how we can execute one. And I'm doing this so that you have a ready reference you can turn to when you're writing or when you're constructing your own chaos workflows. Before we go on to chaos workflows, we'll take a very brief look at Argo project. I mentioned in the introduction that chaos workflows are a result or they are a byproduct of the collaboration between Litmus and another cloud native project called as Argo. So Argo is a project with diverse products or diverse sub-projects. There is an Argo CD which allows you to run your GitOps workflows, that is, ensure that you are able to deploy on your cluster what you have in your Git source. And it also has the workflow engine as one of its sub projects, and we are going to talk about that. So an Argo workflow is essentially a container native workflow. It can do different tasks on your cluster in a sequential way or in parallel. You can embed different manifests that you want to run as part of those tasks, and that's where we're using it to embed our chaos engines to be run as part of a task. Workflows are very useful. You can construct entire pipelines using these. You can automate a lot of mundane tasks that you generally do as part of preparing your cluster for certain operations. And you can also use it as a very good testing mechanism. Having said that, in Litmus, we're using Argo for a slightly different purpose. One of the feedbacks that we received from the community, or we found out as we went along in the chaos journey, is that while standalone chaos incidents occur, when standalone failure incidents occur, the system behaves in a certain way. You might tolerate certain failures under certain conditions, but many times these failures occur either in quick succession or in parallel. You might have pod deletes happening, or you might have pod evictions happening when one of the nodes in your cluster is already in degraded state. You might have network being lost on a cluster in which there is resource exhaustion being faced on certain nodes already. Or you might have disk failures on the different nodes of your cluster at the same time. These are what are called as multi-component failures. And as you go along in your infrastructure journey, you will see that these multi-component failures are not so rare after all. They occur all the time. So it's important to see how the application behaves, how your entire framework, your deployment, your business deployment on Kubernetes is withstanding these kind of failures. And that can help you to build more resiliency into both your application as well as your deployment practices. Another area of interest is running chaos during performance testing. When I say performance testing, typically I'm talking about some kind of a predefined benchmark workload that you're running on your application. And when this kind of a load is being generated, in all probability, you're trying to simulate the load in a busy condition. Let's say you are an e-tailer and you are trying to gear up for some kind of a Thanksgiving or a Black Friday, where there's a lot of traffic that is expected to hit your microservices. You're trying to simulate that using some kind of benchmark tool. Doing chaos on the application or on cluster components during such an activity brings out in greater detail the resilience capabilities of your application stack. So a lot of organizations, a lot of practitioners of chaos generally attempt failures when they have some kind of a load running on the system and not under idle conditions. So as you know, Litmus is a framework that helps you inject chaos. So it is giving you off-the-shelf chaos experiments. It is giving you an orchestration framework by which you can declaratively say, this is the app I want to target. This is the nature of the chaos I want to inject. And these are the chaos tunables. While that is all very well, we still want to be able to do this chaos under certain conditions and derive certain useful information. The chaos result is giving you verdict today, which says an experiment is passed or failed based on some predefined characteristics or predefined entry and exit criteria that has been bound into the experiment. But probably there are more insights that are necessary. You might want to see whether these entry and exit criteria hold true when the system is under stress. When we say stress, either due to certain workloads running on your application or because of a chain reaction of degradations that is happening on the cluster. One failure which before being remediated is seeing another failure on the same system. What happens when a lot of such failures stack up over a period of time? How does the system stand up to it? How does the application respond? This is something that we would like to see. And by the request of the Litmus community, we tried to use the Argo workflows to weave together what is called as a chaos scenario. A scenario is different to just a standalone injection. During a chaos workflow, which we are also going to call as a chaos scenario, there can be a lot of tasks listed in a particular order. You might want to start your benchmark job and parallelly also induce chaos, or you might want to do two chaos experiments in parallel. Or you might want to precondition or warm up your system to a certain state, cause one failure, and then sequentially execute another failure. So Argo workflows allows us to very easily accomplish this. That's when we thought we will create a set of predefined workflows, Argo workflows, which are executing chaos tasks. Now that we know the what and why of chaos workflows, let's go ahead and create one ourselves. In this example, I'm going to run a pod delete chaos experiment when an Apache Bench based benchmark job is being run against the nginx deployment. The hypothesis here is very simple. Without chaos, you're going to get a certain amount of performance from your nginx deployment. Your requests will go through without errors. Whereas when you do the chaos, you're going to see a certain number of failed requests. Typically, the hypothesis in such experiments is around the SLA that you might have promised as a vendor or as an SRE to the stakeholders. The SLA is mostly defined in terms of availability of the nginx service, the performance that you derive from it, the toleration that you have towards certain request failures, etc. By doing this chaos, you can see how your system might behave if there are some forced evictions on the node where the nginx replicas reside, or when a node might have gone down. What happens? Whether the nginx deployment that you have, or it need not just be nginx, it can be any other application that you're using, is it able to survive and meet the SLA that you have set? You can tune the chaos engines by passing different parameters. You can give the kill counts for the pod delete experiment to bring down more than one replica. You can iterate a certain number of times. You can change the benchmark load in the workflow YAML. And you can derive a lot of insights about how your nginx deployment is working on your cluster. You can also create your hypothesis based on the role for which the nginx has been deployed. Have you run it as an ingress controller? Are you using it as a load balancer, etc.? In the session today, I will just use this chaos workflow of doing pod delete against nginx during benchmark as a way to illustrate how you can construct your own chaos workflows. The Argo workflow manifests can be constructed in different ways. There are a lot of different ways in which you can define the tasks to be run as part of the workflow. We've gone for one that's using steps. It is pretty intuitive for people who are doing it for the first time and makes the intent of the workflow very clear. So first we are going to install the Argo infrastructure. That means the Argo workflow controller and the Argo CRDs. We're going to follow that up with installation of the nginx deployment, a multi-replica nginx deployment. That's going to be followed by installation of the Litmus infra consisting of the operator, the experiment CRs. And then we are going to create an Argo workflow manifest with the right service account in order to execute these jobs of running benchmark and executing chaos. And once we create that workflow, we are going to execute it, and we are going to visualize this workflow in a dashboard that's provided by Argo. There's an Argo server which also provides you with a dashboard. So we're going to look at the progress of the workflow using that dashboard. Okay, let's get started. So we have a 3-node GKE cluster on which we are going to do this workflow. So as you can see, there are no namespaces for Argo or Litmus here. I'm going to use the documentation to install them. Let me begin by installing the Argo namespace. This is as part of the Argo infrastructure installation. I have downloaded this manifest which contains all the necessary components needed for the Argo workflows to run, that is the workflow controller and the CRDs. It also has the Argo server deployment and the service. Let me go ahead and use this to set up the Argo infra in the Argo namespace. So it's created the CRDs and the deployments that are necessary. Let me just confirm if all the components are running successfully. I've used a node port service for the Argo server so that we can visualize the chaos workflow using the Argo dashboard on our browser. I'm going to select one of the node IPs and look for the Argo dashboard to come up. So you can see the Argo server is set up and the dashboard is not showing any workflows. The next step is to install the sample nginx application, and this is something that I already have on my cluster. I also have a completed benchmark job from an earlier run, which let me delete that. All right, so we have 3 replicas of an nginx application. We also have the accompanying service. That's something that I've already set up in the default namespace. Now I'm going to set up Litmus infrastructure consisting of the LitmusChaos CRDs and the operator. I'm going to use version 1.7.0, which is the latest stable version of Litmus. I'm going to create the experiment CR on the cluster. I'm going to pull this from the hub. You can see the hub is here. This is the pod delete chaos experiment. I'm going to create this in the Litmus namespace. And the reason I'm doing this is in order for me to run the workflow in admin mode. I'm going to run the chaos using the Litmus admin mode, where all the chaos resources are going to be created in the Litmus namespace, while the applications themselves can reside in other namespaces, in this case default. So I need to use an admin mode RBAC, which is going to serve as the chaos service account. So let me create that in Litmus. And I'm also going to create an Argo access service account. This is an optional step. I'm doing this purely for illustrative purposes. The Argo access service account is something that's going to be used by the Argo workflow controller. It's going to be provided to the Argo pods that the Argo workflow controller is going to create. These Argo pods are the ones that are going to do the individual tasks or steps defined in the workflow. In our case, the Argo access service account is going to have just enough permissions to create the benchmark job and create the engine. It could be anything else. I could be using the same Litmus admin service account to do this as well. But as I said, I'm just going to do this optional step. I'm going to create it in the Litmus namespace. I've just done this to highlight the differences between the chaos service account and the Argo access service account. The next step is to actually create the workflow itself. Let me show you the workflow manifest. We have called it Argo workflow native pod delete YAML because we are using a native Litmus library for doing this pod delete chaos experiment. You can see that this is the CR, obviously, which is being watched by the workflow controller of Argo. We are using the Argo access service account here. There are a certain set of arguments that you can pass declaratively. Most importantly, in this workflow manifest, you can take a look at these templates. So the Argo workflows are composed of templates, and each template can itself be composed of several nested templates. That gives you a lot of scope for defining the flow that you want to do as part of a scenario. In this case, we are going to have 3 steps, each a template. One step is to run the benchmark, another is to run the chaos in parallel to the benchmark. You can observe how the syntax is created. And the other step finally is to revert the chaos and remove the chaos pods and any other resources that are remaining from the run. And each of these templates is defined as an input artifact and a container pair. What does that mean? Now you can take a look at this run chaos step. The run chaos template is composed of an artifact, in our case the chaos engine. The chaos engine here is very simple. It's doing a pod delete chaos experiment that's doing graceful deletes, and it's going to use the retain policy to keep the chaos pods, and it derives the app information from the arguments passed by the workflow. And this engine is being created by another container. So this input artifact is being applied by a container which is running the command kubectl apply. It's doing a few additional things like sleeping for a few seconds to allow the benchmark job to put some requests onto the nginx surveys. We have a very similar structure for the benchmark as well. You can see that this template also is an artifact and container pair, where we are defining a normal Kubernetes job which is doing the Apache bench, and you can see that it is having a certain parameters that's hard coded, notably the requests and the duration etc. being passed as environment variables, number of requests. The service name is something that we are getting as environment variables, and this is something that we created when we created the application. So against this endpoint, the Apache bench is going to run the benchmark load, and we're going to let it run for a few seconds and then inject chaos to see what happens. And finally, we are going to do a revert. Note that there is no input artifact mentioned as part of this step, because this is a straightforward deletion of the chaos engine. We are going to visualize this on the dashboard. So I have not run the vanilla Kubernetes benchmark job against nginx deployment to see what are the expected performance and what are the other parameters in the result. That's something you could do when you're trying this out. We are only going to run the parallel job where the benchmark runs with the chaos, and you will end up with some failed requests. This is just to show how the parallel runs happen. You can tune, like we described or like we discussed earlier, you can tune the engine to do a lot more, drive a lot more insights. You could create a lot of hypotheses based on the nature of the benchmark or the nature of the chaos that you're doing, and derive information by constructing workflows in different ways. Now, I also installed the Argo CLI, which is also described as part of the steps. It's something that I've done earlier in the interest of time. So the Argo CLI is something that's pretty useful. If you're not using a dashboard, you can take a look at this to see what is the status of your workflows. I'm going to do an Argo submit, which is the equivalent of a kubectl apply of this workflow manifest in the Litmus namespace. Before we do that, I'm just going to go back and see that we've created the Argo infra, we've put the application, we've installed the Litmus components, we set up the service accounts for Argo access and Litmus to use in admin mode, and we're now going to create the workflow. And an Argo list command after submitting the workflow is going to say that it has started to run. You can also derive more information by doing an Argo get of the workflow that we just created. We use the generate name API. So you can see that there is a unique hash appended to the workflow. It's currently done with creating the benchmark job. The benchmark job is now in progress, and we are waiting on the Argo job to run the chaos. Let me take a look at the default namespace. The pod for nginx bench has been created. In a short while, you will see the pods for chaos getting created in the Litmus namespace. Remember that we are running in the admin mode, so all the pods are going to get created here, the chaos pods. Right now, you can see that there are some Argo pods. So these are the pods which are generated by the Argo workflow controller to execute the individual steps that are mentioned here. Each of these steps that we saw is going to be executed as by one of the Argo pods. Now, since the chaos also has got started, you can see the runner is here. You can see the pod delete experiment also ran pretty quickly and is done. So let me do this again. You can see that one of the nginx replicas has been killed recently. The age on that pod illustrates that. And you can see that we have not specified any criteria, especially during this experiment. When I say criteria, I mean the entry and exit criteria for the pod delete chaos experiment. Which is why when I look at the chaos result, I can see that the experiment is going to be passed, because I'm not really setting up the right criteria to say your failure count or failure requests should not be more than a certain amount. That's something that you can do declaratively in the chaos engine using the chaos probes. For the current run, which we are just doing for illustration purposes, we have used the default entry and exit criteria, that is to say the nginx service is alive after doing the pod deletes, which is why we say the experiment is passed. The dashboard is going to show something like this. You can see that the experiment has been launched in parallel with the benchmark, and at the end of it, the chaos engine has been removed. So each of these is associated with some logs. You can see that the logs is just to say that the job is created. These are the Argo pods that you saw in the Litmus namespace. Now let me take a look at the output of the benchmark. That's going to give us an idea of what has happened when we run chaos during the load. You can give it a few seconds. Right now you might not see much of an output. So this basically is what your chaos workflow. It's going to help you to run chaos in parallel with either another chaos experiment or a benchmark job, or you could do this in sequence where after doing a pod delete you could do another experiment while the load is still running and simulate some complex scenarios. Before ending this call, and we're going to take a look at the logs, and the log still says it's running because we've got a 240-second duration for the benchmark job. When this completes, you can actually see that the failures have taken place. Some amount of requests have actually failed. You can also take a look at the percentile based latency. What percentile of requests got completed in what latency, which is also a pretty useful metric during such runs. This is what we were mentioning. So you had a certain latency for the requests. This is something that you can put your constraints against. You can also see that there are some failed requests, 36 failed requests because of the pod delete. If you did not have the pod delete, they would have gone through without any failures. Out of these, there are 12 exceptions, which is what is to be noted. And when you do different chaos with a different amount of stress, you might have different values here. You might most probably create your SLOs or SLAs against this value and the latency that you might have see here. And that is something that you can hypothesize around and run these workflows. So this is the demo, just a run through of the steps that are provided in the documentation here. Before ending the call, we said that we will introduce the Litmus portal. Let me come to that. So Litmus portal is something that is going to give you insights into your workflow runs in the chaos context. So there is an architectural document that you can actually take a look, the design spec for the Litmus portal. It has several use cases and personas listed against it. You can always take a look at this. The idea of the Litmus portal is to provide chaos context to workflows. In the Argo dashboard that we took a look here, you could see that it has just represented the nodes that has executed these tasks. But we want to know ideally what has happened as part of your chaos. What pods did it create? What all steps happened as part of the chaos run? That's something that you would want to know. You would also like to display what is the result of the workflow. Not only that, you might also want to know how you have fared over a period of time while running these workflows. You might be executing these chaos scenarios against several changes that you made to your deployment infrastructure or to your business app, and you might want to compare how the workflows have behaved over a period of time. That's something that we're trying to enable with the portal. And not only that, it gives you the ability to create or construct workflows with a few clicks. Instead of having to create it by hand on a YAML editor, you can use the UI to create workflows by just pulling in experiments from the hub. And you can also have a local hub within the portal which is going to store predefined workflows so that you don't have to create a workflow every time you want to run them. You can just use pre-created workflows just the way we created one by pulling a workflow manifest from the repository. You could easily select a predefined workflow from the hub that's defined within the portal. You can tune it and you can run that. It's also going to help you obtain what's called as a resilience score. You can assign weights to the experiments run as part of your workflow. Each experiment can be defined with a certain level of criticality, and you can see what is the overall resilience score that your workflow is reporting for a particular scenario. And over a period of time, as you are in the journey, as you are going ahead in your infra journey or your application journey, you can see how your resilience has improved over a period of time using the resilience score that's reported by your portal for a given workflow or scenario. So these are some nifty capabilities that the portal is coming up with. You can take a look at the portal product design spec here. It is also going to come with certain authentication support where you could connect different clusters to a portal instance running on a different Kubernetes cluster, or you could have a portal trying to orchestrate workflows on the same cluster where it is deployed in. You could invite members of your team to visualize the workflows or to run new workflows and create teams on the portal. And there are other benefits that you would get from it that you can always take a look at and comment upon. So this is something that's going to come up in the 1.8 release as an alpha. So the Litmus portal is being developed in the LitmusChaos/Litmus repo. It's available here. So you can take a look at it. There's a technical preview available. There's a useful README that's here if you want to set it up and get a feel for it. You can create issues around how you want to run your workflows. So in this session, we talked about what chaos workflows are and why they are needed, and how you can construct them, and how you can visualize the result, and how you can basically tune it, etc. In that process, if you feel there is something that you need to simplify, if you feel that there is some capability which is useful to have, please go ahead and create an issue against the Litmus repo with the Litmus portal label, and that's something that we can always prioritize and include in the upcoming releases. So that's about the portal. I just wanted to give a sneak peek of what's going to come up around orchestrating chaos workflows. And in subsequent tutorial sessions, we'll also talk about what are probes. I mentioned it fleetingly when I showed the chaos engine and said that we have not defined the entry and exit criteria based on the application characteristics or the benchmark characteristics. We are only saying whether the app is alive. If you want to declaratively specify conditions to say this number of requests have to be successful, or this should be the tolerance on the failed request, or this much percentile of request should get completed within this much of latency, or any other attribute based on the benchmark run or your application itself. If there's something that the application is exposing via health or as a metric, you can specify probes on the chaos engine to add that as part of your entry and exit checks, and your experiment verdict is going to depend upon that. You're going to get a probe percentage that's also going to be defined on the way these probes are defined. The success percentage of probes for an experiment is pretty useful and directly leads into calculation of resilience scores for your workflow. So that's a topic and a demo for another day. So hope this session was useful in understanding chaos workflows. The workflows are something that was actually contributed by folks from Intuit. A big shout out to them for coming up with the concept of chaos workflows and popularizing that concept. With this, we're going to end this session. Thanks a lot for staying along and being patient and understanding the chaos workflows. In subsequent tutorials, like I mentioned, we'll talk about ways to add probes into chaos engines and execute chaos using the portal. Feel free to take a look at the product design spec of the portal.